So Geordie is we're gonna talk a little bit about tuples.
Oh yeah,
Um,
tuples. Yeah, sure.
so do you, I always hear, especially people that come from MEL or MEL, they ask me, especially when they hear the word tuple,
Yeah.
it's a funny sounding word, first of all, and at the end of the day, is something that is very similar to lists, right?
Yeah,
So
very similar, except
yeah.
you can't change it. It's like locked down.
Okay, so let's talk a little bit about that. What is
Okay.
the main difference between tuples and lists,
Okay.
and when
Sure.
should we use tuples versus lists?
Sure. So I'll just create one real quick. Let me create a list real quick so I can say blah, and I'm just gonna put like cat and the number 13 in there. I'm just making this stuff up as I go along. Okay, so get rid of that stuff right here. So I have an integer and a list, and I've just created. I'm sorry, I have a list, which is square brackets. Let's increase the size here because we don't need to worry about space. Okay, so I have this list, right? So if I wanted to see the kind of things I can look at in a list, I'm going to import this little thing called C. From C, import C. C is this little cool, I want to show it because this is my favorite function. This is my favorite little helper module. From C, import C. It allows you to look into something. So if I wanted to see blah right now, I see all the things I can do with blah. You'll see that as a list, I have the ability to append to the end. I can check the count. I can reverse my list. I can do. I can pop items out of the list. I can iterate through this list. I can do all these things, right? So I just want to show this real quick. So now if I create another one, I'll call it blurb. I'm just making this up. This will be our tuple. And you can create a tuple by putting stuff together in a tuple like this. So I'll also do cat and 13 in this one, right? It's exactly the same so we can see. So, whoops, sorry. Let's do tuple this way. You don't have, tuple is when you cast something as a tuple. Like if I already had a list, I do this. So I'm just going to do this like this. You don't actually have to do the casting method.
Okay.
So if I had this list now and I had blurb, right? Blurb is a tuple, and I'm actually going to do C on blurb. I like using these nonsensical terms. So you'll see that it has a lot fewer functions.
I see.
And that's because it's actually locked down. I can't reorder this. I can't reverse it. So just to compare. So here's list. You can see the result for list here. I have all these functions I can do. And on a tuple, I cannot do that. I can basically look at it and index into it. That's basically all I can do.
I see.
Now, this has a value. And the value comes from what's called being hashable. So are you familiar with hash?
No.
Okay, so
tell me about it.
Hash means something is unique and is not changeable. It is not mutable, which means it's immutable. It's never going to change. I've just assigned this variable blah a list, and this list can change all the time, right? So I can change this list, which means it's mutable. It means I can change like a mutant. So if I tried to hash blah, it's going to give me an error. It's going to be, man, you can't hash lists. They're going to change. They're mutating all the time. They're like X-Men. They're mutants. If I tried to hash blurb, blurb says, oops, hold on. Hash blurb, it gives me this really cool, unique integer, which is a pointer to some memory location somewhere. It's a memory location that says, I've been assigned, and this memory location is never going to change for the value of blurb. So the cool part about it is when you're making dictionaries, you can only use as your keys for a dictionary. You can never use like a list as the key for your dictionary, right? You can only use hashable items, things that are never going to change, because you don't want the address of something to change in your dictionary, right?
Yep.
If I created a dictionary like my dictionary is equal to, whoops. Yeah, so my dictionary is equal to this, and I want to add some keys. So I'll say a list is equal to, let's call it blah, all right? And strings by default are hashable. So if I tried to hash this, it would give me some integer, maybe positive or negative integer location here. Lists are never going to change. Whenever you assign a variable to a string to a variable, that's never going to change. It's immutable. So if I wanted to, I could actually use blurb as the key, or a tuple as a key in my dictionary, like this. So I could say that is equal to something, something, just something. We'll just say something. So I've just assigned a dictionary value using a tuple as a key. Now, what benefit do you think that this could have? I mean, can you immediately offhand think of something that would be useful for that?
No, nothing.
Okay, so imagine if it wasn't just a string and a value. What if it was some x, y, z coordinates, like x, y, and z, right? And those x, y, and z values were like 13, minus 2. Sorry, I'm just replacing the x, y, and z. And 45, right? So these could be x, y, z coordinates of, say, a joint.
I see.
This could be x, y, and it doesn't have to be an int, right? It can be a float, so I can make a float one of these. And when I go to instantiate my dictionary, nothing happens. It's not an error, nothing like that. If I try to do the same thing with a list of floats or whatever values, and I try to make a dictionary doing this, bam, it's going to crash because lists are unhashable. They're mutable.
I see.
So tuples occupy less memory too. So you can use them as keys in dictionaries, which I have this PyMail thing that I'm going to be doing where I have this puzzle. Let's see if I can find the puzzle here. I have this wooden puzzle that I actually created, and I wanted to write some PyMail to solve this puzzle. It's called a Coronado puzzle or something. Where the heck is it? I wish I had it here. Anyway, no, I don't know where it is. My kids probably moved around. Any event, it's like look, think of it as like a Rubik's Cube, and you're placing really weird shaped odd things, and you're trying to solve this puzzle so everything fits inside of a cube, right?
Yep.
I use like a dictionary for the names of these pieces, and when I position them in space, I use their position in space as like a value of like 1, 2, or 3 in the x, y, and z, so I know where the center point of my piece is as I rotate it around to see if it fits in this volume.
Oh, interesting.
So I have what ends up happening is I will have a list of positions that are valid positions for the name of some piece. And when I get like 9 of those pieces and they're all inside the value, that means the puzzle is solved. And so what I can do is I can pause there, duplicate it, and move it over, and then show the solve right there in screen. I wish I could show that right now. It'd actually be pretty cool. But I haven't touched that code in a while. So, but what I end up doing is I have a dictionary of all these positions, x, y, and z. And so I can use those to place things in space. It's pretty super useful. You can also use it for like color schemes and stuff like that.
That's true. That's really cool.
Yeah. Anyway, so one last thing on tuples is they actually occupy less space memory. I can show that to you. I can prove it to you by showing the bytecode, but that might be overkill for tonight. I don't know.
Go for it.
Okay. So there's this function called dis in Geordie. So dis is for disassembling things. It'll actually print out like the bytecode behind things, which is kind of funky. It'll look odd. So if I had a function, let's just check it out. Let's just create 2 functions real quick here. I'm just going to do that real quick here. Real quick. We'll just create 2 functions. So def a, and that will just have a list in it, right? So we'll just say x is equal to, and we'll just create the same list here. B. Okay. So this a will have a list. The exact same function for b will have a tuple. Okay. Okay, we'll just call it b, and we'll just make these a tuple or a tuple. I call them both. There's raging wars online about what they should be called.
I was going to ask that.
Yeah, it's funny because everybody says something different. So I'm just going to define these 2 functions, right?
Yep.
Scroll down here and give myself some breathing room here. So dis has this really cool mechanism where it'll show you the bytecode, and which each one of these steps represents like something to do in time. So if I say dis.dis and I say a, I'm just going to look at the bytecode for a. And you can see the bytecode for a. So let's do the same thing for b. So we'll do dis.dis on b, and we'll see that it's actually shorter. So see, 1, 2, 3, 4 steps, and the same 4 steps exist in the list, but then it has these other values here, like loading construction. So setting values and will both be the same, but extracting values is a little different, I think is the way to look at this. So this just means there's more bytecode, which means the list is a little heavier, just a little bit. But if you have thousands of them in the scene, then you're just choking a little bit more memory down than you would if you have a tuple.
That's cool.
And to put that, and just to wrap this up, most of the Python commands that come inside of Maya require tuples.
Yep.
So you've probably discovered this as your coder as well.
Yep.
But you could just pick any one of these, like whatever, and any one of these arguments should require like a Boolean, a string, or let's see, let's do orient constraint, because I know that one. Orient constraint. Let's just do that one. That one requires a bunch of arguments that are actually tuples. The funny thing is it actually shows them like lists here.
Yes.
Yeah, which is not good because they generate this from Python docs, but then somebody has to go in here and put in these little documentation where you actually have to put tuples in. And this isn't really a good example because they also make this code. These help docs, they just basically modify the mel and put it in here. It's pretty bad, but like for some of these arguments for like offset, this is actually not supposed to be a list of floats, and it'll kind of choke out on you unless they've added something new where it converts it. But it should be a tuple, and that's
the last example there. It shows the CC, the create cache.
Which one? Where is it?
The very last example at the bottom of the page.
Oh, it does. Yeah. So normally you cannot put any lists as arguments in here and into any of the Maya commands. And you might be pulling your hair out because you're looking at this and you're like, this is clearly a list of floats. And then you go down here and it's clearly a tuple of floats.
Yep.
So I wish they'd fix that, but oh well.
Awesome. I mean, that was a great explanation of tuple or tuple, and I would invite people to suggest how else it can be pronounced. Cool.